So today we're going to talk about building functions from functions. In other words, we're going to take two functions and we're going to make a new function. Okay? So we go to page 110. There's a definition, there's a blue box there. So let's take a look at that. We have the sum, difference, product, and quotient functions, okay? So these are new functions, okay? So if I say f plus, let's say that f of x is equal to x squared. If I have f of x is equal to x squared and I have g of x is equal to e to the x, okay? Let's say I'm going to make a new function called f plus g of x, and that would be the sum function. Now we're adding these two together, right? Okay. Or I can do like this and go like this. Right? I can also say that f times g of x is equal to x squared e to the x, right? So I'm building from two functions. I am finding ways to make a new function, okay? So let's say, so that's that. So we have the product, the quotient, and all this good stuff. So let's go to example number 1 and see if we can actually do this. So I have example number 1. We have f of x is equal to x squared. And then we have g of x is equal to square root of x plus 1. Find the formulas for the, so the sum function would be what? X squared plus square root of x plus 1. The subtraction function would be this guy. You're just subtracting it. The multiplication would be this. And then if you have f of x over g of x, you're going to get x squared over square root of x plus 1. Really nothing earth-shattering here, right? It's all stuff that we know, okay? So that's example number 1. We're going to move on. So that's it. Blah, blah, blah. Okay. Actually, there's something that's kind of, okay. So let's go to the page 111. There's in the middle, there's a definition. There's a new blue box there. Composition, the composition function where we have f dot g. F dot g is a fancy way of doing this. Okay, so wherever, so if I had f of x is equal to x squared, and I had g of x was equal to e to the x, right? So wherever x is, I'm going to put this guy in here for f of x. So this is going to be what? I'm going to put e to the x where x is. So it's going to be e to the x squared, right? Which is basically e to the 2x, right? Now let's see what happens when I swap this around. G dot f, okay, is going to be different because now this is going to be g of f of x. So wherever x is, I'm going to, where in g of x, I'm going to put f of x in. So in g of x, wherever x is, I'm going to put x squared. So it's going to look like that. You can see that definitely there's a difference between the two, right? So f dot g and g dot f are not always going to be the same. And as a matter of fact, most of the time they'll be different. Okay, so that's the composition. Okay, that's the composition function. Okay, so let's go to example number 2 and see if we can do this. Example number 2. F of x is equal to e to the x. And g of x is equal to square root of x. Just find the f of g, f dot g and g dot f. So we got f dot g is equal to f of g of x. So in f of x, we're going to put this guy in here. So it's going to be e to the square root of x. G dot f is going to be g of x, f dot x. So wherever in g of x, we're going to put f of x in there. So it's going to be square root of, wherever x is, I'm going to put this guy in. It's going to be like that. Okay? So that's that. And so that's good. Let's go to example number 3. Example number 3, and see if we can do the domains. Example number 3, if we have f of x equal to x squared minus 1, g of x is equal to square root of x. Find the domains of the composite functions g dot f and f dot g. So g dot f is going to be wherever g is. I'm going to put f of x in there. Okay, so I'm going to get what? I'm going to put this guy in wherever this guy is. So then it's going to be like this, right? X squared minus 1. We have to find the domain, which is this function, the x's, right? So what is the x going to be there? So x has to be what? This guy here, x squared minus 1, has to be greater than or equal to 0. That's the domain, right? That's the implied domain, right? Okay, because it shows there. So I'm going to have x squared has to be greater than or equal to 1, which means that x is negative 1 or x is greater than or equal to 1. Okay, so that's my domain. Okay, let's do the f dot g. The f dot g, we're going to get what? So this will be f of g of x. So in f of x, I'm going to put this guy in here. So I'm going to have square root of x, x squared minus 1. So it's going to be x minus 1. Okay, so this in itself does not have a restriction. Okay, however, since g of x, the domain of g of x is what? The domain of g of x is x has to be greater than or equal to 0, right? So you have x is greater than or equal to 0. So you have a domain that goes in there already. You have a restriction in here. So even though this as a function by itself alone doesn't have a restriction, this carries that same restriction, the domain restriction right here. So your domain is going to be this, okay? And then we have example number 4. We're going to go backwards now. Example number 4. Example number 4, I'm going to give you the result, and you're going to have to come up with an f of x and g of x that satisfies it, okay? So A, for each function h, find the functions f and g such that next works. So I'm trying to find a function. I'm going to give you this function, and you have to find, which is the same of f dot g, you have to define f and g for me, okay? So A, we have h of x is equal to x plus 1 squared minus 3x plus 1 plus 4. So this one is fairly obvious, right? Fairly obvious because you have this guy, and this guy that is exactly the same. And it looks like you have put that into something, right? So what goes in the x's is going to be your g of x, right? So you can see that the g of x here would be x plus 1. And the f of x is going to be equal to x squared minus 3x plus 4, right? Because now when you do f dot g, right, this guy here, wherever x is, you're going to put this guy in. So wherever x is in f of x, I'm going to put this guy in. I'm going to put x plus 1 squared minus 3x plus 1, and the plus 4 just carries on. And you can see the composite function h is f dot g. Okay, again, it's kind of obvious because of the x plus 1s here, the x plus 1s here, right? And in B, we have the h of x is equal to square root of x cubed plus 1. Okay. So here, I could say that g of x is equal to x cubed plus 1, and f of x is equal to square root of x, right? Because wherever the x is, I'm going to put this guy in. I'm going to put it in there, right? Okay. But that's not the only one that works, right? There are other things that work too here, right? If I went like this, that would work too, right? Because now wherever x is, I need to put x cubed in there. And it becomes x cubed plus 1, right? And it becomes that guy. So you can see when you're going backwards, there are several different functions that work. Actually, matter of fact, there are many ones that work. I can go like this and say this is minus 1. So now when I put x cubed plus 2 in here, I'm going to get what? Square root of x cubed plus 2 minus 1. And this is the same as x cubed plus 1. Okay, so there's several different ones that you can put in here that work. Okay, you have to find just one. Okay, when I ask you to decompose the function, okay, you just have to give me one. All right, because any one of them will work, really. Okay, let's look at example number 5. Modeling with function composition in the medical procedure known as an angioplasty. Doctors insert a catheter into a heart vein through a large peripheral vein and inflate a small spherical balloon on the top of the catheter, on the tip of the catheter, I'm sorry. Suppose the balloon is inflated at a constant rate of 44 cubic millimeters per second. So it's 40, so this is example number 5. So the rate of change of the volume is 44 millimeters cubic per second. A, find the volume after t seconds. So after t seconds, the volume is going to be what? It's going to be 44 t, right? Because each second you're going to add this much more, right? So it'll be 44 t. B, find the volume V when the volume is V, what is the radius? So this is nothing more than the equation that we know, 4/3 pi r². That's the volume of a sphere. C, write an equation that gives the radius r as a function of time. What is the radius after 5 seconds? Okay, so what do I know? I know that this volume here is going to be equal to this volume here, right? So in C, all I'm doing here, in C, I'm going to set these two equal to each other. And I'm going to solve for R here. I want to solve for writing an equation that gives the radius as a function of time. So the radius is a function of time. So I'm going to solve for the radius here. So I'm going to get what? I get 44t. And then I'm going to multiply both sides by 3/4, 3/4, because that cancels out. So multiply this by 3/4 is equal to pi r². This is 11, so I get 33t is equal to pi r³. Divide both sides by pi. I get that. So r is going to be the cube root of that. Okay. All right, so we'll stop right here for the part 1, and then we'll do part 2 later.